In the previous section, we defined the derivative of f as this limit. Let's repeat. F of x plus h minus f of x over h, if the limit exists, and we use this definition and some process to find the derivative step by step for several function. Now we want to develop some rules of differentiation. So it is not easy task always to use this limit. So by using some well-known limit, we can calculate the by using some known derivative, we can calculate the derivative of the more complex function. Okay. So briefly, these rules will enable us to find the derivative of many functions without using this limit. Before exploring these rules, we will list some symbols that are often used to represent the derivatives. So you know that f prime, one of them, f prime of x. Sometimes just we write f prime. Instead of the f of x, we can use the y, so y prime is also derivative of our function. And we have Lipschitz notation, which is dy over dx. This means derivative of the y with respect to x, and similarly derivative of the f of x with respect to x notation can be used. So all of them are representing derivative of the x. Our first theorem, actually as a theorem it is given in your textbook, theorem. By using definition you can show that easily, this is not difficult. Derivative of the constant function is 0. If y equals f of x is a constant function c is any real number, then f prime of x equals 0. So for example, f of x equals 2 function, derivative of f prime is 0. Also you can denote y prime equals 0, dy over dx equals 0, etc. Okay. Maybe this notation a bit complex for you. So derivative of the, here instead of the f of x I will write the c, derivative of the c with respect to x equals 0. So that means is this one. From the graph you can observe this situation. Also analytically you can show that if the function graph is the constant, so this is the c graph, there is no change of the f value. F is always constant, so this numerator is 0. Our second important rule is the power rule. It's a theorem too I would like to give, but I'm not sure in your textbook how it is given. The theorem, yes, again, as a theorem it is given, and now I'm checking. So if the function y equals f of x equals x to power n, here n is a real number, any real number, it does not have to be an integer, okay, then f prime of x equals n times x to power n minus 1. Of course, also you can use the following notations: y prime equals n times x to power n minus 1, and dy over dx equals n times x to power n minus 1, or let's write, this is also correct, derivative of the x to power n with respect to x equals n times x to power n minus 1. This is called the power rule. And the next one is the constant multiple properties. So as a theorem 3, if y equals f of x, which is defined as a key times some constant factor times u of x, and I assume that you know the derivative of the u of x, so derivative of the f equals key times derivative of the u. Okay, this is called the constant multiple rule or constant multiple properties. Okay. Next rule or properties is sum and difference properties. So if function f of x is a summation of the u and v function or differences of the u and v function, then derivative of the f of x equals derivative of the u of x plus derivative of the v of x. If this is differences, this is also differences, okay? So this is the another important rule or properties for the derivative. And we have another properties which is a power rule, but it is a bit complex when comparing these two rules, okay? So because of that reason, it will be given in the next section or following sections. On the other hand, I would like to emphasize it is possible to use any combination of these facts. For example, let's give an example. If our aim is to calculate the derivative of the following function, 6x to the power 4 minus 3x cubed plus pi is constant, x squared plus 2x minus pi plus 2, for example. For this function, easily you can calculate the f prime. F prime x equals, first you have a 6. So derivative of the 6 is constant, key times by using the constant multiple rule, 6 times derivative of the x to the power 4 with respect to x. And by using differences rule, minus, and 3 is constant factor, 3 times derivative of the x cubed with respect to x, plus pi is constant by using summation rule and the multiple production rule, derivative of the x squared with respect to x, and plus 2 times derivative of the x with respect to x. Maybe this parenthesis is not necessary. And derivative of the minus or plus, okay, derivative of the pi with respect to x plus derivative of the 2 with respect to x. This should be minus, sorry, okay. So by applying the power rule, 6 times derivative of the x to the power 4 is if n is 4, so 4 times x cubed over x cubed, sorry, 4 times x cubed. Maybe we can change some things in the question. Instead of the 2, let's write 3 over 2. 3 over 2. So minus 3 times derivative of the x cubed is 3 times x squared by the power rule. Pi times derivative of x to the power 3 over 2. N is 3 over 2. So 3 over 2 times x times 3 over 2 minus 1. Okay, 3 over 2 minus 1, which is 1 over 2. Plus 2 times derivative of the x with respect to x is 1. Minus derivative of the pi with respect to x, pi is constant, 0. Derivative of 2 is 0 again with respect to x. So 24 x cubed minus 9 x squared plus 3 pi over 2x to the power 1 over 2. If you want, you can write it as square root of the x, plus 2 is the derivative of this function. It is possible to use any combination of this rule in the questions.